Okay, I got kind of a hybrid system going on here. I got a solar hot water heater, 5 kW of solar electric, and a 2.5 kW wind turbine. The solar water heater is a drain back system. I have I think 64 square feet of panels. Okay, you're looking at the controller for the solar hot water heater. The collector up on the roof, it has 163 degrees in it right now, and the storage tank has 153 degrees in it. And the storage tank is simply a standard electric 80-gallon hot water heater. I keep the breaker to that turned off. I don't have any issues at all, unless I have an extremely heavy use day where a whole bunch of people are over. And here's how the system works. There's a heat exchanger up in the attic, and down here at the bottom where you have your drain that came out of the drain, which is the bottom of your tank, is the coldest area, and it goes up, and here's a circulator pump, and it's circulating the water through a heat exchanger up in the attic, and then back down into the cold side of the standard water heater, and then it comes out just on your hot side like normal. And then I had to install a mixing valve because it was so hot, and I have this set to 130 so nobody gets hurt because the water gets so hot. And there's like I said, there's a heat exchanger up in the attic, which there's a heat exchange fluid in that, and there's another pump up there that pumps the heat fluid through the solar hot water heater up on the roof, the collector on the roof, and back into the storage, back into the heat exchanger. And then so there's two loops going. And so you never have any of your, when the system shuts down, all the water on the roof comes back into the heat exchanger, so you have no freeze problem at all. There's no way it can freeze, which is nice. It works automatically. When I have it set to 160, when the storage tank gets to 160, it shuts down. And I got 24 Sanyo HIT solar panels, 215 watt apiece. Solar panels go into a Sunny Boy 5000 US inverter, grid tied. And the wind turbine goes into this ARE voltage clamp, and then into an SMA Windy Boy 3000 US inverter. And if the wind turbine's producing too much power that the inverter cannot take, it goes into this load dump here. It's sitting on top of a 75-foot tilting tower. So it goes from the wind turbine into that voltage clamp, into the inverter, into the grid. And then there's the load dump on the right. Okay, it's 4 o'clock in the afternoon. My whole house is going, and I'm still going backwards. when this arrow is pointing this direction, it means you're feeding back into the grid, and when it's going that way, you're buying power. I got it's called the Energy Detective, and I have a iPad up there for the display, and MTU1 is what my house is using right now, 4,290 watts. MTU2 is what the solar panels are making. We got 5 kW solar. And MTU3 is what the wind turbine is making. I got a 2.5 kW wind turbine made by ARE. And right now I'm going backwards. This is the net. It means I'm going backwards at 2 kW right now. Solar panels are making over 5,000 watts. The wind turbine's making 1,000, and my house is using 4,500. And I am still going backwards. I got a 4-ton air conditioner going. It's 93 degrees out here right now. I got the air conditioner set at 75. I got a 2.5-ton air conditioner set at 75. I got 2 full-size refrigerators on, a deep freezer, a commercial ice machine using 1,000 watts. The ice machine uses 1,000 watts by itself. It makes 270 pounds a day. I have it going on a timer where it only comes on from 11 a.m. to about 5 p.m. when I'm still making good solar power. Here's the grid disconnect, which the utility makes you put in. I pull that lever and it shuts down the solar electric system and the wind turbine. Still going backwards. I got a couple computers going, 2 laptops, a full-size computer, monitors going, TVs going. I'm going back at 2 kW right now. See, the wind turbine's making over 3,000 watts. It's only a 2.5 kW wind turbine.